So I am making this video actually for my friend, but as I intended to do a video, so I believe that it might be benefits to others. So I'm going to make it public, and I hope you guys understand. So, however, let's say if I did anything mistake or anything wrong, you can just tell me because it's fine. Everyone did mistake. Everyone do mistake. So example 13, the right circular cone has a radius of 12 centimeter, height 20 centimeter. Find the radius and height of the cylinder that fits inside the cone and has the largest volume. Hence, he determined the largest volume of the cylinder. So when they are mentioned the largest volume of the cylinder, so simply mean the radius and the height of the cylinder going to be the largest as well. The height I'm talking about is not the height of this cone, but the height of the cylinder. And the radius I'm talking about is not the uh, radius of the cone, but the radius of the cylinder. Okay, so now this is a figures that I make represent this one, but it's like I make it half like this. Okay, so when I make it half like this and I make it like 2D, it's going to be like this. This is not actually exactly the stem, but this is just figures so that we can understand and what we going to do. So first, we assign the variable. So I assign the r to be the radius of the cylinder, h to be the height of the cylinder, and v to be volume of the cylinder. Okay. So now, the formula of volume of the cylinder is equal to pi r square h. This is volume of the cylinder, the formula. And where does this coming from? Of which you might like, where is it coming from? And why do we need to do this? Okay, first, to find the extremum. Okay, to find the extremum, we need to do derivation. Derivative. So let's say like v. But the problem is we cannot have two variable in we cannot have two variable to do. We can have, but we want only one. Okay, because what? Because to get the extremum, we want the v to be 0, right? So if we have two variable h and r, then how can we find one of the value? We need only one variable. So in this situation, we need to either change this into r or change this into h, of which I decide to change this into r. Because of why? Because this one got square, which is going to be way more complicated, but yet it is still applicable if you want to do so. So okay, back to the question, like once I get the hash, so it's in the term of r, so I insert the hash here. So I using this one going to here, then we get only r. This one is r, this one is r, so we have only r, so we can do the extremum to get the value of the r. Okay, to do derivative and get the value of r. So but how I get this one? So here you can see over here 28 minus hash per r equal to 28 per 12. So where do I get this one as well? I get this one is coming from this. Okay, so now, so okay, look at here. So I have extract this one, as I mentioned previously, into this form. So this one is the 28 centimeter height of the this triangle, which coming from this one 28. Okay, and this one is 12, which is this one is 12. I'm not write it here, but it's supposed to be 12. Okay, so right now we only want this one, but how can we know this one? So we can do the ratio. Okay, so now if you realize, we have two circle here. First we have this circle, and next, okay, we have this big circle, and this circle is exactly the same but different ratio. So what can we do? We can do the ratio. Okay, so for this one, for this small cute circle, we find the r here. And what is this? Okay, this one is 28. And this one is hash. Okay, look. As I make it hash. So this one, what going to be here? It's going to be 28 minus hash. So this one is 28 minus hash. Okay. And now, how about the big circle? Okay, the big circle, you just follow this one. So the big circle going to be 28 and 12. Okay, so now we get these two features, of which we can do the ratio in this form, which I made the ratio. Okay, so when I made the ratio, I do some sort of algebra and I got the hash this. I made the hash single and I got this one, of which I insert to this. Okay, and I insert, then I got this one. Okay, now we have finished. We have made the volume into one term only, which is R. And now we need to do the derivative to make it 0. Okay, so I make it 0 over here. Okay, so now this one make it into dv per dr and then equal to 0. Actually, it's not yet 0, but okay, this one is why I do this one? I kind of forget. Okay, you know what? Never mind. Just forget the 0. But you need to make it equal to 0 because you want to find the maximum or the minimum, extremum. Okay, so if I'm not mistaken for this one, it's like I factorize. But actually, you don't need to factorize, to be honest. I mean, like, you don't need to factorize. You can just leave it like this. I mean, like, just leave it this way. And then, this one, you just bring it here. Minus 7 pi r square equal to 0. Okay, now, when you do the 0, okay, like this, you will get these two answers. Okay. Now, maybe some of you are going to say, well, we want to find the maximum, so it's obviously r equal to 8. And yes, you are correct, but you cannot skip the step to proving, which is the proving. We need to do the second derivative. Okay, so in proving, we need to do the second derivative. So this one is first derivative, right? So we need to derivative again. Okay, and this one is second derivative, of which I derivative from here. Okay, try to derivative this one, you will get this one, because this one is second derivative. So the second derivative is used to know the maximum or minimum. Okay, now what we going to do? So we know the r, so we going to insert the r. Okay, so I'm going to insert the first r is equal to 0, and we will get this one. Okay, so when the value is more than 0, this one more than 0, so it is minimum. So the r over here, when the r 0, it's produce the minimum volume of cylinder. Okay, and when we insert the r equal to 8 into the equation, so we get that the value is less than 0, and when it is less than 0, so the volume going to be maximum. Okay, so when the volume is maximum, so the r for this one is to get the maximum. So that's why r equal to 8. R equal to 8 is the maximum. Okay, so now what we gonna do is that the formula of hash, we make it like this one, isn't it? Like this one, hash. So insert the r equal to 8 here. So when you insert, you will get the value is this. So this one is the maximum hash. Okay, so now what you're gonna do next is that v equal to pi r square hash. You're going to insert the r at, and hash is 9.88. So when you insert, you will get this volume. Then this volume is the maximum volume. Actually, this one is the old way I do. Actually, I have another way that is more practical. I didn't really use this one. Actually, I am prominently to use okay, I am prominently to use this one, like v, like this one. So when I'm going to use 0, I'm insert the 0 here, which is I find it more practical. Or if I want to use add, I'm going to insert add over here. And over here, when I finish doing this, I'm going to, actually I'm not really going to make it like this way. I'm going to make it like equal. Okay, let's say this, I'm not sure the number, but let's say it is 3. So after I get after I get the value of 3, then I'm going to do this v, this one is double because second derivative, and then the r you are using is 0, is bigger than 0. Okay, and same goes with this one. Let's say I got the value is a negative 2, then I'm going to make v 8 be less than 0. Then I'm going to proceed. Like I'm going to make this dot, and I'm going to mention that the volume is maximum, because this one is represent the volume. Okay, the volume is maximum when the r is equal to 8. So the r equal to 8 is the maximum. Okay, so there's like different things I did in this video, because this one is the old way I do, but people improve, so I using a more practical way. But it's up to you. You can use this one, or you can use the one that I just present. Okay, so that's all from me. Thank you very much, and that is my finger, and thank you.